I've often wondered what alien life might look like, and today, we're going to explore some mind-bending possibilities. Our journey begins right here on Earth, where life thrives in the most extreme environments imaginable. From scorching hydrothermal vents to frozen wastelands, life finds a way. But what if we take this adaptability and apply it to worlds beyond our own? Before we venture into the cosmos, let's consider the incredible diversity of life on our own planet. Earth's extremophiles, organisms that thrive in conditions that would be lethal to most life forms, provide us with valuable insights into the potential for life elsewhere. Take, for example, the tardigrade, a microscopic creature capable of surviving in the vacuum of space. Or consider the bacteria found in the Mariana Trench, enduring crushing pressures and complete darkness. These extraordinary adaptations challenge our preconceptions about the limits of life. The physics of these situations forces life to evolve in ways we might never have imagined. And it's this adaptability that opens up the possibility for life to exist in the most unexpected places across the universe. Now let's consider our first hypothetical alien world, Kuiper. This planet orbits a red dwarf star called Oculus, but here's where it gets interesting. Kuiper is tidally locked. This means that one side of the planet always faces its star, while the other remains in perpetual darkness. The physics of this situation creates an environment unlike anything we see on Earth. On the day side, intense radiation and heat make life as we know it impossible. The night side, conversely, is a frozen wasteland, but what if life could thrive in the narrow band between these two extremes? This twilight zone where day meets night might just be the perfect cradle for alien life. In this twilight zone of Kuiper, we find a shallow black ocean. The water here isn't blue like on Earth, but black, absorbing as much of the dim red light from Oculus as possible. This adaptation allows the ocean to retain heat, creating a stable environment for life to evolve. But what kind of life could we expect in such an alien sea? The constant twilight conditions would require life forms to develop unique sensory abilities. Perhaps creatures here have evolved to use sound or even electrical signals to navigate and communicate, much like some deep-sea creatures on Earth. The physics of light absorption in this black ocean would create a world of shadows and subtle gradients, a far cry from the vibrant colors we're used to in Earth's oceans. At the heart of Kuiper's ocean ecosystem, we find something familiar yet alien: black kelp forests. These massive structures form the foundation of life in this twilight world. In the dim red light of Oculus, black is the most efficient color for photosynthesis. These kelp forests play a crucial role in oxygenating the ocean and providing shelter for a myriad of alien creatures. The physics of fluid dynamics in this environment leads to unique adaptations in the kelp structure, optimized for capturing nutrients from the ocean currents. Now let's populate our black kelp forests with some truly alien creatures. In this low-light environment, life forms rely on bioluminescence for communication and camouflage. Imagine creatures with skin that can change texture rather than color, blending seamlessly with the kelp or the ocean floor. Predators in this alien sea might use echolocation like Earth's dolphins, but with much more precision due to the constant need for such skills in this dark environment. The physics of sound propagation in water could lead to the evolution of complex sonar systems far beyond what we see on Earth. Let's shift our focus to our second hypothetical planet, Nimbus. This gas giant is similar in composition to Neptune, but with a crucial difference: life has evolved not on a solid surface, but in the clouds themselves. In the upper atmosphere of Nimbus, where temperatures and pressures are similar to Earth's surface, we find a complex ecosystem floating in the alien sky. But how does life survive in an environment with no solid ground? The answer lies in the unique adaptations that allow organisms to stay aloft permanently in the gaseous layers of the planet. At the base of Nimbus's aerial food chain, we find cloud plankton. These fascinating creatures are small, spider-like organisms that have evolved an ingenious method of locomotion. They generate electrostatic threads, similar to a spider's silk, but with an electric charge, allowing them to move through the gaseous medium of Nimbus's atmosphere. The physics of electrostatics in this environment would be crucial. These creatures might use the planet's magnetic field for navigation, much like some birds do on Earth. They could potentially harvest energy directly from the electrical potential differences in the atmosphere, a form of metabolism entirely alien to Earth life. Higher up in Nimbus's food chain, we encounter truly massive creatures, sky whales. These enormous, gas-filled beings are the gentle giants of this alien world. They float effortlessly through the atmosphere, their bodies adapted to maintain neutral buoyancy in the changing pressures of the gas giant's layers. At the apex of Nimbus's aerial ecosystem, we find the jet squids. These predators have evolved to hunt the massive sky whales, using a form of jet propulsion to move swiftly through the gaseous medium. Imagine a creature that can compress and expel the atmospheric gases with tremendous force, allowing for rapid acceleration and precise maneuvering. As we conclude our journey through these hypothetical alien worlds, I hope I've sparked your imagination about the potential forms life might take in the universe. If you're fascinated by these concepts, I highly recommend checking out Brilliant.org for fantastic courses in physics, astronomy, and biology.